Okay, we'll go on and look at another one or two in this particular set. So we're going to look at number 5 this time. The limit as x approaches 3 of 1 over x plus 1 minus 1 over 4, all divided by x minus 3. And so we'll bring in the graphing calculator. Now this time, assuming we have time in the 5 minutes we have here, the instructions say at the end, use a graphing utility to graph the function to confirm your result. And we'll try at the end not only to use the table function but also to use the graphing function to see if we can get a visual confirmation as well. So we open up the calculator again, and we need parentheses for the whole numerator. So that'll be parentheses and then 1 divided by parentheses x plus 1 close parentheses and then minus 1 over 4. Now even though that's in parentheses in the problem, technically for the order of operations we don't need those parentheses there. But we do need to put the whole numerator 1 over x plus 1 minus 1 over 4 in parentheses, and then that will be divided by parentheses again x minus 3 close parentheses, and we're all set. We'll go in to make sure that we're in independent ask and then second and table, and we may have leftover values, x values from before, but that doesn't matter. We're approaching 3 this time, so 2.9, we get negative 0.0641. We'll go to the next value, which is 2.99, and there we get negative 0.0627. Next we'll do 2.999, and we get negative 0.0625. So this is a similar example to the last time where we're not really sure where this is going. I might want to put in, even though the problem is not asking for it, and now I can see that my limit is at least negative 0.0625. I'm comfortable with that, and I'm going to put in values from the right now. We're going to start at 3.1, and we get negative 0.061. Then 3.01, negative 0.0623. Next 3.001, and we're down to negative 0.0625. And so we record that. Now we'll actually go ahead and look at the graph of this function. Since we have some time, we'll do a zoom and then option number 6, which is Z standard. Now we can't see a whole lot there, so what I'm going to do is adjust my window to go from negative 5 to positive 5 and see if that helps at all. Now what you see there is a vertical asymptote. Now the calculator is trying to connect the two sides of the asymptote, but we don't really even care about that. We're more concerned with around x equals positive 3. So you can see there it's very close to the x-axis. So I'm going to adjust my window again. This time I'm going to adjust the y values. Instead of going from negative 10 to positive 10, we'll only go from negative 2 up to positive 2. And then take a look at the graph and see what happens there. Well, we can see that as we're approaching 3, if I actually wanted to look at the value at 3, I do second calc and then value. I can plug in 3, and I can see that there is no value to this expression when x is equal to 3. However, if I were to just move the arrow around, notice I'm at 2.978 right now, around 3. Actually, I should be using second and trace. Just trace. There you go. Now when x gets close to 3, y is close to negative 0.0625.